Hey everyone, in this section of our mini thermodynamics lecture, we're going to be talking about energy. So energy can be defined as the ability to produce work. You can also think of it as the capacity to produce a desired effect. So we measure using SI units. So SI stands for International System. So the SI units for energy will be 1 joule. 1 joule is equal to 1 Newton times 1 meter. We have 1 kilojoule. 1 kilojoule is of course equal to 1,000 joules. All right, we have what's called the rate of energy use or change. Rate of energy use of change. All right, so we have there 1 watt. 1 watt is equal to 1 joule per second. And then we have 1 kilowatt, and that's about 1,000 watts. All right. If we're not dealing with SI units, the international system, we're looking at EE units. So this is the English engineering units. So 1 BTU, you've probably heard of that before, and that's about 778.1693 feet pounds force. All right, 1 BTU is also equal to 1.055 kilojoules. All right, again, we have the rate of energy use, or the rate of change, power. So we look at it in horsepower. 1 horsepower is equal to 550 feet pounds force per second, and that's about 2,544.4 BTU per hour. All right, 1 horsepower is equal to about 0.7457 kilowatts. And we look at it as 1 ton of refrigeration is equal to 12,000 BTUs per hour. All right, let's look at the types of energy. The types of energy. So, in looking at this, the different types of energy that we're talking about in this mini course will give us what's called the total energy. So, one type will be internal energy. Another type will be we call potential. And then the third type will be, you probably guessed it, kinetic. So the internal, potential, and kinetic are the types of energy. So the total energy of a system is the combination of the system's internal energy, potential energy, and kinetic energy. The total energy of a system is the combination of all of these. All right, let's hop into potential energy. Potential energy. So what is it? So potential energy is the energy in a system resulting from the system being in a gravitational field, and is due to the mass of the system being higher than some reference point. The formula we use is PE for potential energy equals mgc. Here, m is the mass of the system. The g is the acceleration, and this is due to gravity. and the Z. The Z is the height of the system. So it's the height of the system, and this is above a reference point. The height of a system above a reference point. All right, the next type we can talk about is kinetic energy. Kinetic energy. So kinetic energy is the energy present in an object as a result of its motion. Again, it's the energy present in an object as a result of its motion. So we have kinetic energy is equal to 1/2 mv squared. All right, where our v stands for the velocity of the system. V is velocity of the system. So the faster an object is moving, then the greater the kinetic energy. All right, let's look at an example. So we're looking at types of energy, and specifically an example here that says to determine the potential energy and the kinetic energy. So that's what we'll do. Determine the kinetic energy and the potential energy. And we'll say it's of a rock. And let's tell more about that rock. A 2 kilogram rock that's falling from a cliff. A 2 kilogram rock that is falling from a cliff. Let's say when the rock is 20 meters above the ground. So the rock is 20 meters above the ground. And then we'll also give more information and say that it's traveling at 15 meters per second. All right. We'll make some assumptions, or they'll give us some assumptions. They'll say, let's assume that the cliff is located at sea level. So the cliff is located at sea level. All right, so determine the kinetic energy and potential energy of a 2 kilogram rock falling from a cliff when the rock is 20 meters above ground and traveling at 15 meters per second. We'll assume the cliff is located at sea level. All right, so here's our solution and how we work it out. First, the strategy will be to look at what's given. Well, given is the m, the mass, 2 kilograms. The z value is 20 meters. V is 15 meters per second. And what we know already from gravity being 9.81 meters per second squared. All right, so now we can go ahead and work through the solution. Well, potential energy equals mgz. So we have 2 kilograms times 9.81 meters per second squared times 20 meters. Just crunch those a bit in your calculator and we get 392, the units are joules. Kinetic energy is 1/2 mv squared. So we have 1/2 times the mass, again, of 2 kilograms. And the velocity is 15 meters per second. And then we square that, crunch those numbers in your calculator, we get 225 joules. All right, let's go a little bit further. Now we go into internal energy. So internal energy. So the internal energy of a substance is all of the energy present at the molecular level. Again, the internal energy of a substance is the amount of energy present, all of the energy present at the molecular level. All right, so when we look at internal energy, we want to look at intensive properties and extensive properties. Intensive properties and extensive properties. So for intensive properties, these do not depend on the quantity of matter. There are things like pressure or temperature. Extensive properties, they do depend on the system's size or amount of material in the system. So these are things like energy, volume, or enthalpy. So let's look at the total energy of systems. And we're looking at extensive properties. So here we're looking at E equals U plus KE plus PE, right? Which gives us U. We know that KE, the kinetic energy, is 1/2 mv squared. The potential energy is mgz, as given. All right. So let's go ahead and take a look. Let's consider the following. All right, so we're looking at 1 kilogram of liquid. 1 kilogram of liquid. And let's just say 1 kilogram of liquid water at about 20 degrees Celsius. And they are telling us that it's moving at 50 meters per second through a pipe. Moving at 50 meters per second, through a pipe. And the pipe is 20 meters above the ground. All right, they're giving us that U is equal to 83.9 kilojoules per kilograms. All right, so now let's look at the contributions of each type of energy, right? The contributions of each type of energy. So we have U, which is M times U. So that's 1 kilogram times the 83.9 kilojoules per kilograms. Crunch those numbers a bit, and we'll get 83.9 kilojoules. KE is the 1/2 mv squared. So there we have 0.5 times 1 kilogram times 50 meters per second. And we square that. Crunch the numbers with your calculator. We get 1,250 joules, or 1.25 kilojoules. And then lastly, we look at PE, which is mgz, and that's 1 kilogram times 9.81 meters per second squared. And that's times 20 meters. And we get 196 joules, or about 0.196 kilojoules. All right, so this was our basic introduction to energy. If you're available for the next video will talk about more on the transfer of energy. Have a great one.